So welcome back. This is going to be our last video on proofs, because after this we'll have covered every single proof you need to know for your Leaving Cert, and also the kind of methods to prove things. So the abstract inequalities and the proof by induction, they're kind of questions they can ask on proofs, and the official proofs we all covered. So the square root of 2 is irrational, the 3 theorems, and de Moivre's theorem. So this is our final one. After this we can move on to another topic. So we have to prove by induction that de Moivre's theorem is true, and de Moivre's theorem says that if you have a complex number in the polar form, so de Moivre's theorem, if you go back to our complex number videos, you'll see it's at the end of those videos. So it says that if you write a complex number in the polar form like this, that or multiplied by cos theta plus I sine theta all to the power of n, instead of multiplying that out and taking forever, is equal to or to the power of n by cos of n theta plus I multiplied by sine of n theta. So this just makes it a lot quicker if you use de Moivre's theorem. So yeah, we're going to have to prove this by induction. So we're going to go through it the normal way. So we're going to start with step 1, is we're going to prove it's true for n is equal to 1. So prove true for n is equal to 1. So that means I'm going to write on this side, it's going to be in brackets, or then cos theta plus I sine theta, and then finish the brackets, to the power of 1 is equal to or to the power of 1 by cos of 1 theta plus I sine of 1 theta all multiplied by 1. And this is true because 1 theta is just theta, so it's the exact same as what we have here. So true for n is equal to 1. Next we have to assume it's true for n is equal to a k. So I'm going to write that. 2, we're going to assume true for n is equal to k. So if we write that out, let's scroll down and write this out. That means that we have, again, square brackets, we have or multiplied by cos theta plus I sine theta to the power of k is going to be equal to or to the power of k multiplied by cos of k theta plus I sine of k theta, close the bracket. Alright, so we can assume that that is true. And again, this might seem like a lot of kind of ors and i's and causes and k's and thetas, but it's not too bad. Yeah, once you go over complex numbers and once you just kind of learn this off, it really isn't too bad, just putting the k's and the n's in the right places. 3, now we have to prove that it's true for, so prove true for n is equal to k plus 1. Alright, so what are we going to do? We're going to write the same thing out again first. So we're going to write square bracket or multiplied by cos theta plus I sine theta, close the bracket, to the power of k plus 1, and this should be equal to or to the power of k plus 1 multiplied by cos of k plus 1 by theta plus I sine k plus 1 theta, close the bracket. Alright, so that might seem a bit messy, but that's what we have to prove. So we're going to leave the right hand side the way it is and just try to prove the left hand side is equal to that. So the first thing I'm going to do is I'm going to break this up on the left, again using indices. So that means we're going to get, so it's going to be square bracket or multiplied by cos theta plus I sine of theta, close bracket, to the power of k, and then it's going to be multiplied by or multiplied by cos theta plus I sine theta multiplied all to the power of 1. Again, that's indices, so this to the power of k times this to the power of 1 is equal to this to the power of k plus 1, so we're just going backwards here. Yeah, I'm going to leave the right hand side as it is. So now this, what we have here on the left, or multiplied by cos theta plus I sine theta all to the power of k, is what we assumed up here. So we assumed that from step 2, so again we're always going to sub something in from step 2. So instead of this, we can now write this here, which is a little bit nicer. So that means I'm going to write or to the power of k cos of k theta plus I sine multiplied by k theta, and that's all in brackets, and then this is still or multiplied by cos theta plus I sine theta and in square brackets to the power of 1. After this, you have to deal with the messy business of just working through all of this, and there's a few lines until you get to a line where you simplify it, so I'm just going to rush through that. Alright, So if you multiply or by the or here, you're going to get or to the power of k plus 1. So if we multiply cos k theta by cos theta, we're going to, so that the or is already multiplied, now we just multiply what's inside the brackets here by what's inside the brackets here. So cos k theta by cos theta is just going to be cos k theta cos theta, and cos k theta plus multiplied by plus I sin theta is going to be plus I cos k theta sin theta, and then I sin theta by cos theta, or I sin k theta is going to be, so again this is just really messy and it takes a while. The last line is the most important one basically, because the rest of this shouldn't be a problem to work out. So this is plus an I by this is going to be I squared sine k theta sine theta. Alright, so quite messy. Just make sure you keep your head on you. That's going to be minus 1. Okay, so that's going to be minus 1. And sorry, that I there isn't super clear. I'll just write that in a little bit better. Plus I. So next what we're going to do is we're going to write that as minus 1. And also we're going to group these together. So we're going to write then that or to the k plus 1. And I'm going to write it over here is going to be cos of k theta, cos of theta, minus sine of k theta, sine of theta. And then both of these together is going to be plus I. So what I'm going to do is I'm going to write both of them on this side, and I'm also going to factorize the I out. So then we're going to have cos k theta sine theta plus sine of k theta cos of theta. Again, this is just super messy. So now you're at the final step. So this here you can turn into a trigonometric identity, and you can have a look through and you can try and figure it out if you want, or you can learn off the last line. So once you get to this here, you have to use trigonometric identities to simplify it. So I'm going to go up and go across to finish that off. So the next line is going to be or to the power of k plus 1, like we had. The first trigonometric identity is going to simplify down to cos of k theta plus theta, alright? And then the second one is going to be plus I multiplied by sine of k theta plus theta. Alright? And then one more line, then we have or to the power of k plus 1 multiplied by cos. I'm going to factorize theta out of here. We're going to get k plus 1 by theta plus I sine, and factor theta out again, k plus 1 by theta. And we're left with our final thing. So that's what we had on the left hand side, and we wanted to prove that that was equal to this on the right hand side. No, sorry, not this on the right hand side, to this on the right hand side, which we have proved. So I'll just go back over. So again, this is messy, it's not all on the one page, but it is a bit of a messy proof. It's just one of those things you just have to learn off. I'm going to say therefore true for n is equal to k plus 1, for n is equal to k plus 1. And that means by induction we can say, so I'll do the proper fourth step out, and there we have the fourth step written out. It's the same steps as we've been using so far for all the proofs by induction. So I know that video wasn't exactly the prettiest and most interesting video, but that's the kind of proof it is. It's just a little bit of a monster that you have to learn off and be able to repeat. So it just gets quite messy doing all those cos thetas and sin thetas and k thetas and stuff like that. But if you learn it off and it does come up, that's going to be a handy 15 marks for the exam. So we definitely would recommend learning it off. So anyway, that's it for proofs by induction and just general proofs for the Leaving Cert course. So after watching all of those, you're able to do every single proof they can ask you for the exam. So I hope you enjoyed the videos. Make sure to share them with your friends and like and subscribe, and we'll see you in the next set of videos. So we have videos on every other topic, so make sure to check some of those out.